This is Albert, and this is Albert Mini. This might be the smallest fully self-powered open source robot dog ever built. Same 8 degrees of freedom as the full-sized version, just fits in your hand. But fitting everything into this small design was a challenge. Getting here almost didn't happen because of one part. I didn't have to code and train the robot. Thanks to LLMs, I could just ask for complex tasks in natural language, and he figured out exactly how to execute them. All this project is open source. Code, 3D models, everything. If you like projects like this, sharing it helps a lot. If you've seen something smaller with these specs, let me know in the comments. I'd love to see it. To make this work, I had to redesign the body around a specific goal. I wanted Albert Mini to fit in my hand, but I still wanted to use standard SG90 servos, so they are easy for everyone to buy. But because the upper leg is so small, I had to create a special design where the horns of the two servos actually partially overlap. It took some fine-tuning to make sure they didn't collide, but it allowed me to keep the full 8 DOF motion in a tiny footprint. Inside, I used a servo driver to control the motors and an ESP32, which I fixed right on top of the box that makes the body. For more info on how to connect everything, check out my previous videos on the topic. I'll leave the links in the description. Then came the battery. To make design even smaller, I could have used a tiny LiPo battery, but that would mean low capacity, short run times, and I'd need a dedicated step-up module. Instead, I decided to use a standard power bank. By placing it right on top of the robot, it solved the balance issues and gave me hours of battery life. It's not that bad. It actually looks like a nice hat. One thing I really focused on was making sure the design stayed modular. Everything is easily fixable. Here you can see me replacing a broken servo in less than a couple of minutes. Now, here's how the brain works. I don't command him by hard-coding every move. First, I inform the LLM about his physical build, his joints, and his 8 degrees of freedom for locomotion. Once Gemini understood the body, I could just ask for behaviors in plain English. I can tell him to do push-ups, swing, dance, or even jump. I'm basically just the coach. The AI figures out the motor positions to make it happen. Here you can see a few examples, but you can imagine many more. Let me know in the comments. It's not always perfect, but it's changing how I do robotics forever. The smaller these get, the more interesting it becomes. You can build a sophisticated quadruped right on your desk. Next step, making him fully autonomous. What behavior should I ask Gemini to try next? Let me know in the comments. Also, let me know if you are interested in a video comparison between ChatGPT, Gemini, and Claude to see which one is actually better at understanding a robot's body and generating motion. Go grab the files on GitHub to start your own build. I'll see you in the next one.